Our topic for today is AC circuit, that is alternating current circuit. From the name, alternating, that is that alternate, that change periodically. Now, when we say AC circuit, we mean the circuit profile for the flow of alternating current. Then, what is an alternating current itself? Alternating current is current produced from time-dependent alternating voltage, which vary periodically in a way to change its direction sinusoidally. That is, in the case of direct current, don't forget, direct current has positive terminal and negative terminal. But in case of alternating current, it has only live wire and neutral wire, and it changes its terminal periodically, alternatively. Therefore, that's why we call it alternating current. Now, under today's topic, we have some terms that you need to know and you'll be coming across, such as peak voltage, peak current. That is peak. We have peak voltage and peak current. We have I root mean square. Then we have instantaneous I, ordinary I. We have peak voltage, peak current, instantaneous voltage, instantaneous current, that is ordinary I. Then I root mean square, then V root mean square. Now, what is meaning of peak voltage or peak current? Peak voltage, from the name peak, the maximum current in the circuit. While peak voltage is maximum voltage in the circuit, it is denoted with what? With V naught, like this. That is peak. Then we have instantaneous voltage. That is the voltage at every instant of the conductor. That one is ordinary V. Then we have V root mean and I root mean. That is the current that will produce the same amount of heat in the same conductor at the same time. So then, what is their relationship? So, because the current flow sinusoidally, that is periodically, it takes the waveform. Then we have it like this. So to go up, down, and down, and so on and so forth like this. This point is called peak. It may be peak voltage or peak current. This is where we have what? Peak here. Then at any instant of this flow, we have what? Instantaneous current of voltage. Then we have I root mean. Then because it takes sine form, that's why we call it what? Sinusoidal wave. So in that case, we are going to relate them like this. We have ordinary V, that is instantaneous voltage, is equal to V naught sine theta. Instantaneous is equal to V naught. Don't forget, this V naught is peak sine theta. The same thing applicable to what? To current. I is equal to I naught sine theta. And don't forget, what is our theta? Our theta is equal to omega t, where omega is 2 pi f. We've done that under simple harmonic motion. Therefore, we can replace this theta with 2 pi f t. We now place it here. So our I will be equal to I naught sine omega t. Or we have V as well. V is equal to V naught sine omega t. Take note of this formula very well, because we are going to make use of them as we are going along the explanation. Then we have the root mean. See, from here now, there's no root mean square here. Root mean square of voltage or current, as I said, is the voltage that will produce the same amount of heat in the same conductor at the same time. Now, so we have I root mean. Very simple. I root mean square is equal to I naught over square root of 2. That's why we call it what? I root mean. Therefore, I, that is the peak current, is equal to I root mean multiplied by root 2. The same thing applicable to what? Voltage. V root mean is equal to V naught over square root of 2. Now let's go on to the main part of the topic. So under AC circuit, the direct current that we have that we did before, we can only have resistor in the circuit. But when we are talking about AC circuit, it's not only resistor that oppose the flow of current. So we have inductor, then we have capacitor. Therefore, we have three things that can oppose the flow of AC circuit. Then, in a circuit that contains only current, AC circuit that contains only resistor, so in that case, the voltage and the current, they are going to be in phase. That is, they are going to follow Ohm's law that says V is equal to IR. I said they are going to be in phase. It means that when the voltage reaches its maximum, that is the peak value, the current also will reach its peak value. In that case, we have the waveform like this. If this is the current, so the voltage also will be something like this. If you look at it very well, you see that this is where we have maximum value of current. Then this is where we have maximum value of voltage. So in that case, we are going to say they are in phase. They are in phase. That is, they have maximum and minimum at the same point. So in that case, if voltage is equal to V is equal to V naught sine omega t or sine theta, let's use theta directly. So current also will be I is equal to I naught sine theta. And that is when you have only resistor in the circuit. What of the circuit that contain only capacitor? If there is any circuit that contains only capacitor, what will happen is that capacitor will delay the flow of voltage. So in that case, the voltage, the current will lead voltage. Current will lead voltage by 90 degrees. I said current will lead voltage when we have what capacitor in the circuit. Therefore, we can say current and voltage will lag current. It's still the same thing. Therefore, since current will lead, if voltage is equal to V naught sine theta and is the current that will lead, it means that of current will increase, this theta will increase by 90 degrees. So in that case, we have I is equal to I naught sine open bracket theta plus 90. So in some cases, they replace theta with what? Pi. So pi is 180. Now, what of the circuit that contain, what of the waveform of this? So in that case, we have it like this. Because we said in the case of resistor in the circuit, both of them will be in phase. It means if current is here, I, voltage also will be here, V. But in case of capacitor in the circuit, that current will lead. If voltage is here, I, voltage is here, then current will lead, then current will be here. And they are going like this. It shows that, this shows that current lead voltage by 90 degrees. That's all. But in a circuit that contains inductor, because inductor will delay current, so inductor act like a resistor. store what? Current. In that case, the current will lag, the voltage will not lead current by 90 degrees. So in that case, we have, if in the case of inductor in the circuit, if I is equal to I naught sine theta, and don't forget, in the case of inductor, voltage will lead. So now the V is equal to V naught sine theta plus 90. Or if voltage is equal to V naught sine theta, then current will not up to theta by 90 degrees. You can add what? Current is equal to I naught, that is instantaneous current, is equal to peak current sine open bracket theta, this theta minus 90 degrees. So that is that about that. Then in the case of the vector diagram, for the vector diagram, we have it like this. So if for the inductor, voltage will lead. If current is here, I, voltage will be here, V. Or if voltage, if current is here, just make sure that the current, the voltage lead current by 90 degrees. If you have to draw the vector diagram, you draw it like this, and you must put what? The arrow there. So that is that about a circuit that contains only capacitor. Now, for in that circuit, we said we have three devices there. We have resistor, which all know that the symbol for resistor is this. Then we have capacitor, which we are familiar with before. Then we have inductor. Inductor is like coil. Now, the opposition over by this resistor is called resistance. But the opposition over to the flow of AC circuit by the capacitor is called capacitive reactant. Capacitive reactant. And we have what? We use F like this. XC. For this one, the opposition over to the flow of AC circuit is XL, where L stands for inductor. Now, in general, when you are asked to define resistance, that is opposition over to the flow of AC circuit by resistor. But what of reactant? Reactant is the opposition over to the flow of AC circuit or current by either capacitor or inductor or both of them. Therefore, the opposition over by this capacitor, we can call it what? Is what? Capacitive reactant. But when I say reactant alone, it means it may be this or both. But if I say capacitive reactant, I'm referring to only this. Then what is the formula to find it? Formula for finding this one is 1 over 2 pi Fc, where F is the frequency. Then for this one, they are almost the same formula, but only slight different. This one is inverse, this one is direct. This one will just give us like 2 pi Fn. So to calculate inductive reactant, we use 2 pi Fn. To calculate capacitive reactant, we use 1 over 2 pi Fc. 2 pi Fc. Therefore, if you have the two of them in the circuit, the effective opposition to the flow of AC circuit will be what? The difference between two of them. You deduct that of capacitive from inductive. Therefore, we have X is equal to XL minus XC, which is equal to 2 pi FL minus 1 over 2 pi Fc. So this one is effective reactance when we have two of them in the circuit. And take note, we don't call it impedance. It's only when you have this one that we can call it impedance. When you have only capacitive capacitor, we can call it reactant. When we have only inductor, we call it reactant. But when we have both of them, we still call it reactant. But the resistor is not there. Now, in the case where you now have two of them, three of them in the circuit, we call it impedance, and that will be the beginning of the next video. Now, let's quickly solve this question to make the class more explanatory. For the question number 1, they said an AC supply is connected to an electric lamp which lights with the same brightness. What are they referring to? They are referring to root mean square. Which light with the same brightness as it does with direct current source, EMF. That is, this value given to us is what? V root mean. The peak PD, peak potential difference of the AC supply is that. So in the question, they gave us V root mean. Then we are looking for V naught. Then what is their relationship? Don't forget, in our previous formula, we have V root mean square is equal to V naught over square root of 2. So we just apply your calculator. V root mean square is equal to the value given. The V root mean square is given, that is 6. When I say 6 is equal to V naught over square root of 2. Cross multiply, our V naught is equal to square root of 2 multiplied by 6. So that is that one. Then the next one, the next question is this a 10 microfarad. This symbol means microfarad, that is 10 raised to the minus 6. A 10 microfarad capacitor is connected across a 100 V root mean square value of 40 and 50 F AC supply. Determine the capacitive reactant. Hence, find the high root mean. Capacitive reactant. So in that case, you go directly to what? To formula for capacitive reactant.